Statistics is a branch of mathematics that deals with the collection, classification, and analysis of numerical data. We know the methods to represent data graphically and in a tabular form. We also know different methods, mean, median, and mode, to determine the central tendency of a collection of data. The central tendency gives us a rough idea where the data is centered. That is, it tells the location of the data. However, the measures of the central tendency are not sufficient to give complete information about the data, such as its spread. Let's look at an example. The table shows the data of marks scored by a student in 8 subjects. Let's represent this data as dots on the number line. Here, we can see that the data are scattered along the line. This scattering of data can be measured by using the methods of finding the central tendency. Thus, we need to measure the dispersion to define the spread of the data. Statistics that signify the extent of the spread of items around the measure of the central tendency is known as dispersion. It is a single number to describe the variability. Let's look at another example. The marks secured by 2 students, Rohan and Dinesh, in 8 subjects are shown here. The mean of the marks obtained by Rohan and Dinesh is 60. Their median scores are equal and are equal to 60. Now, let's plot the marks on number lines. Here we notice that Rohan's marks are close to each other and centered about his average score. On the other hand, the marks scored by Dinesh are scattered on the number line. Thus, the measure of the central tendency is not sufficient to give us complete information about the data. Hence, in order to decide the performance, the variability of the extent of the numerical values is necessary, which is called the central dispersion. In this module, you will learn to find the mean deviation for ungrouped data. We know that the deviation of an observation x from a fixed value k is equal to x minus k. For the sake of convenience, we take the mean or the median as the fixed value k. To find the dispersion of the observations from its central tendency, like the mean and the median, we need to find the deviations about the central tendency. The mean of these deviations gives the absolute measure of deviation. However, we know that the central tendency is the middlemost value of a given data if they are arranged in the proper order. Half of the deviations are negative and the others are positive. Therefore, the sum of the deviations about the mean is 0. Let's prove this result. Let the observations be x1, x2, x3, and so on up to xn. The mean of the observations is equal to the sum of the observations divided by the number of observations. Now, the sum of the deviations is equal to x1 minus the mean, plus x2 minus the mean, and so on, plus xn minus the mean. Let the sum of the observations be k. Therefore, the sum of the deviations is shown here, On simplification, we get the sum of the deviations is equal to 0. Hence, the sum of the deviations about the mean is 0. This implies that the mean of the deviations is 0. Let's find the mean deviation about the mean of an ungrouped data. Let the observations be x1, x2, x3, and so on up to xn. To find the mean deviation about the mean, first find the mean of the given observations. Let this be k. Next, find the deviation of each observation from the mean. This can be obtained by subtracting the mean from the observation. Now, find the absolute values of deviations obtained in the previous step. Find the mean of the obtained absolute values of deviations. This mean is the mean deviation of the observations about the mean k. This can also be written in the summation form as shown. Similarly, the mean deviation about the median is shown. Let's look at an example where we need to find the mean deviation of the given data. The mean of the given data x bar is equal to the sum of the observations divided by the number of observations. This is equal to 54. Now, we'll find the sum of the absolute values of the deviations of all the observations from the mean x bar. We get the sum of the absolute values of the deviations equal to 82. Therefore, the mean deviation about the mean is equal to the sum of the absolute values of the deviations divided by the number of observations. This is equal to 9.11. Let's look at another example where we need to find the mean deviation about the median of a given data. First, we'll arrange the data in ascending order to obtain the median. Now, the median of the given data is the middlemost observation, which is the 5th observation. Therefore, the median is 50. Next, we'll find the sum of the absolute values of the deviations of all the observations from the median. This is equal to 114. The mean deviation about the median is equal to the sum of the deviations divided by the number of observations. This is equal to 12.66. Hence, the mean deviation about the median is 12.66. In this module, you will learn to find the mean deviation about the mean for grouped data. We know that data can be grouped in two ways: discrete frequency distribution and continuous frequency distribution. A collection of data consisting of distinct values occurring with certain frequencies is called discrete frequency distribution. Here is an example of discrete frequency distribution. The table displays the data of the performance of 50 students in a math test. In case of a large number of observations, We classify the data into different class intervals without any gaps along with their respective frequencies. Such distributions are called continuous frequency distributions. An example of continuous frequency distribution is shown here. The table displays the marks scored by 50 students. Let's begin with finding the mean deviation about the mean for discrete frequency distribution. Let x1, x2, x3, and so on, up to xn, be the n observations with frequencies f1, f2, f3, and so on, up to fn respectively. The mean x bar of the data is equal to the sum of the products of the observations and the respective frequencies, whole divided by the sum of the frequencies. Here n is the sum of the frequencies. Now, the deviations of the observations xi from the mean x bar is xi minus x bar, where I is equal to 1, 2, 3, and so on up to n. Next, we'll find the absolute values of the deviations. Finally, the mean deviation can be obtained by finding the mean of the absolute values of the deviations. This formula gives the mean deviation about the mean of a discrete frequency distribution. Let's consider the weights of 20 students. To find the mean deviation of the given data, we'll first find its mean. The sum of the products of the observations and the respective frequencies is equal to 1000. Therefore, the mean x bar is equal to 1000 divided by 20, which is equal to 50 kilograms. Let's find the modulus of deviation of each observation from the mean. Now, we'll find the sum of the products of the deviations of the observations and the frequency concerned, which is equal to 20. Therefore, the mean deviation about the mean is equal to 20 divided by 20, which is equal to 1. Next, we'll find the mean deviation about the mean of a continuous frequency distribution. Let's consider the frequency distribution shown here. In such cases, to find the mean of the data, we need to find the mid-values of the class intervals. Let's denote them by xi. Now, we'll find the product of the mid-values and their respective frequencies. The sum of the product of the mid-values and their respective frequencies is equal to 2600. Therefore, the mean x bar is equal to 2600 divided by 50, which is equal to 52. If the number of observations is large, then the mathematical calculations may be tedious. In such cases, we can use the assumed mean method or the step deviation method to calculate the mean. Next, we'll find the modulus of the deviations of the mid-values from the mean. Now, find the product of the deviations with their respective frequencies. The sum of the products of the absolute values and their respective frequencies is equal to 768. Therefore, the mean deviation about the mean is equal to 768 divided by 50, which is equal to 15.36. In this module, you will learn to find the mean deviation about the median for grouped data. We know that data can be grouped in two ways: discrete frequency distribution and continuous frequency distribution. Let's find the mean deviation about the median for a discrete frequency distribution. Look at the data of the heights of 50 students in a class. We'll find the mean deviation about the median of the given data. Let's first find the median height of the data. As we notice here, the heights are arranged in ascending order. Now, the cumulative frequencies are calculated as shown. The cumulative frequency that we obtained is shown. Here, the number of students is 50, which is an even number. Thus, the median of the data is the average of the 25th and the 26th observations. As we can notice from the table, the 25th observation is 150 and the 26th observation is also 150. Therefore, the median of the given data is 150 centimeters. Next, we'll find the absolute values of the deviations of the heights from the median 150. Now, the products of the deviations and their frequencies are obtained as shown. The sum of the products of the deviations and their frequencies is equal to 93. Now, the mean deviation about the median can be calculated by using the formula shown here. Therefore, the mean deviation about the median is equal to 1.86 centimeters. Let's find the mean deviation about the median of a continuous frequency distribution. Consider the frequency distribution table given here. It shows the grouped data of a tree plantation program conducted in 60 schools. To find the mean deviation about the median, we first need to find the median of the given data. The cumulative frequencies are calculated as shown. The cumulative frequencies for each class interval are shown. Since the number of observations is 60, the median is the 30th observation, which lies in the class interval 45 to 65. Thus, class interval 45 to 65 is the median class. Now, the median of the group data can be calculated by using the given formula. From the frequency distribution table, L is the lower class limit of the median class equal to 45. N is the total number of observations, that is 60. CF is cumulative frequency of the previous class of the median class, which is equal to 20. F is the frequency of the median class, which is 14. And H is the length of the class interval, 20. On simplification, we get the median as 59.28. Now, the mid-values of the class intervals are obtained as shown. Next, we'll find the absolute values of the deviations of the mid-values from the median, 59.28. Now, the products of the deviations and their frequencies are obtained as shown. The sum of the products of the deviations and their frequencies is equal to 1314.24. Now, the mean deviation about the median can be calculated by using the formula shown here. Therefore, the mean deviation about the median is 21.904. In this module, you will learn about the limitations of the mean deviation. You will also learn to define variance. Many times, the degree of variability in a data is high. In such cases, the median cannot be considered as a central tendency. Thus, the mean deviation about the median will not be sufficient. Again, during the calculation of the mean deviation of a data about its mean, we ignore the negative signs of the deviations. This results in the sum of the deviations from the mean being more than the sum of the deviations from the median. Thus, mean deviation about the mean is not more scientific. For calculating mean deviation, we consider the absolute values of the deviations. Thus, we cannot carry out further algebraic operations. Therefore, mean deviation about the mean or median is not sufficient to measure the dispersion. So we need to extend the measure of dispersion to an appropriate measure of dispersion. Variance is such a measure of dispersion. We know that, to find the mean deviation of data, we take the absolute values of the deviations from the mean or median to eliminate the negative sign of the deviations. To avoid the difficulty of the negative signs of the deviations, an alternative is to take their squares. Let's consider n observations, x1, x2, x3 and so on, up to xn. The mean of the observations, x bar, is equal to the sum of the observations divided by n. Now, the deviations of the observations from the mean are shown. The squares of the deviations are x1 minus x bar whole squared, x2 minus x bar whole squared, and so on, up to xn minus x bar whole squared. Now, the sum of the squares of the observations can be written as the summation of xi minus x bar whole squared, where I is running from 1 to n. From this result, we can infer that if the sum of the squares of the deviations is 0, then each deviation is 0. That is, there is no dispersion in the data about the mean, since all the observations are equal to the mean itself. And if the sum is small, then the observations are closer to the mean. Hence, the degree of dispersion is low. If the sum of the squares of the deviations is large, then the degree of dispersion is high. Let's take the mean of the squares of the deviations. This is called variance. The variance of a data is the mean of the squares of the deviations of the observations from the mean. This is denoted by sigma squared. This is the formula used to calculate the variance of an ungrouped data. Similarly, the formula for the variance for a discrete frequency distribution is given by sigma squared equal to 1 divided by the sum of the frequencies, multiplied by summation of the product of the squares of the deviations from the mean and their respective frequencies. The formula for the variance for a continuous frequency distribution is given by sigma squared equal to 1 divided by the sum of the frequencies, multiplied by summation of the products of the squares of the deviations of the mid-values from the mean and their respective frequencies. Let's consider the given frequency distribution table of trees planted in 20 schools in a tree plantation program. We'll find the variance of the given data. To find the variance of the given data, we first need to find the mean of the given distribution. Let the number of trees planted be xi and the number of schools or frequencies be fi. The total number of schools or sum of frequencies is equal to 20. Now, we'll find the product of the trees planted and the number of schools that planted them. The sum of the products of the numbers of trees and the schools is 320. Therefore, the mean of the frequency distribution is 320 divided by 20, which is equal to 16. Next, we'll calculate the deviations of the numbers of trees planted from the mean. Now, the squares of the deviations are calculated as shown. The product of the squares of the deviations and their frequencies are obtained as shown here. The sum of the products of the squares of the deviations and the frequencies is equal to 700. Therefore, the variance is 700 divided by 20, which is equal to 35. Please note that if each item is increased or decreased by a fixed constant, then the variance does not alter. In other words, variance is independent of change of origin. For any arithmetic series, variance is equal to the square of the common difference multiplied by n squared minus 1 whole divided by 12. In this module, you will learn to find the standard deviation of grouped and ungrouped data. Let's look at the weights of 5 students. The mean of the given data is 52 and its variance is 6 kilograms. Here, it is clear that the unit of the observations and the mean is kilogram, while the unit of the variance is kilogram squared. Thus, the variance cannot give proper information about the data. In order to overcome this ambiguity, we take the positive square root of the variance, thus making the unit of the observations and the square root of the variance the same. This positive square root of the variance is called standard deviation. Standard deviation is the positive square root of the variance. It is denoted by sigma. Therefore, the standard deviation of the given data is equal to 2.449 kilograms. The standard deviation of the observations x1, x2, x3, and so on till xn is given by sigma equal to the square root of 1 divided by the number of observations multiplied by the summation of the squares of the deviations of the observations from the mean. This is the formula for the standard deviation for ungrouped data. We know that the variance, sigma squared, is given by the formula shown here. Let's expand the summation. On rearranging the terms and simplifying, we get x1 squared plus x2 squared plus so on till xn squared whole divided by n minus 2x bar multiplied by x1 plus x2 plus so on till xn whole divided by n plus n multiplied by x bar square whole divided by n. we know that the sum of the observations divided by the number of observations gives the mean of the observations. On simplification, we get that variance is equal to summation of xi squared divided by n minus summation of xi divided by n whole squared. Therefore, the standard deviation of an ungrouped data can also be calculated by using the formula square root of summation of xi squared divided by n minus summation of xi divided by n whole squared. We know the formula for the variance of a discrete frequency distribution. Here, the xi's are the n observations and the fi's are the frequencies of the observations. N is the total frequency and x bar is the mean of the given observations. Thus, this expression is the formula for the standard deviation of a discrete frequency distribution. The alternate formula for the standard deviation of a discrete frequency distribution is as shown. Let's find the standard deviation of the data given that has 20 observations. To find the standard deviation, we first need to find the mean of the frequency distribution. The products of the observations and their respective frequencies are 18, 60, 56 and 126. The sum of the products is 260. Therefore, the mean of the frequency distribution is 260 divided by 20, which is equal to 13. Now, the deviations of the observations from the mean are -7, -3, 1 and 5 respectively. The squares of the deviations are 49, 9, 1 and 25 respectively. The product of the squares of the deviations and their respective frequencies are 147, 54, 4 and 175 in that order. The sum of the products of the squares of the deviations and the frequencies is equal to 380. Therefore, the standard deviation is equal to the square root of 380 divided by 20. This is equal to the square root of 19, which is 4.36. Hence, the standard deviation of the given data is equal to 4.36. If the frequency distribution is continuous, then the formula for the variance is 1 divided by n multiplied by the summation of fi multiplied by the square of xi minus x bar. Here, the xi's are the mid-values of the class intervals and the fi's are the frequencies of the class intervals. Similarly, x bar is the mean of the frequency distribution and n is the total frequency. Thus, this expression is the formula for the standard deviation of a continuous frequency distribution. Let's derive an alternative formula for the standard deviation of a continuous frequency distribution. Consider the formula for the variance of a continuous distribution. On expanding the whole square, we get the step shown. Let's simplify the expression obtained. This is the alternative formula for the variance of a continuous frequency distribution. Therefore, the alternative formula for the standard deviation is obtained as shown. In this formula, note that there is no need to find the mean and deviations of the frequency distribution. The standard deviation of an arithmetic series is given by sigma equal to the modulus of the common difference multiplied by the square root of the square of the number of terms minus 1 whole divided by 12. If the standard deviation of the observations x1, x2, x3, and so on till xn is sigma and k is a constant, then the standard deviation remains the same, even if we add or subtract a constant to each of the observations. If each of the observations is multiplied by a constant, then the standard deviation is also multiplied by the same constant. If each of the observations is divided by a constant, then the standard deviation is also divided by the same constant. In this module, you will learn to find the variance and standard deviation using the shortcut method. We know that the formula for the variance for a discrete frequency distribution is sigma squared is equal to summation of the product of the squares of the deviations from the mean and their respective frequencies whole divided by the total number of frequencies. The formula for the variance for a continuous frequency distribution is sigma squared is equal to summation of the products of the squares of the deviations of the mid-values from the mean and their respective frequencies divided by the total frequency. Many a times, the values of xi in the discrete frequency distribution or the mid-values in the continuous distribution are large. In such cases, we end up doing heavy calculations to find the mean, variance, standard deviation, and so on. To avoid such tedious and time-consuming calculations, we use the step deviation method by working with an assumed mean. Let the assumed mean be A. The deviations of the mid-values of the class intervals about the assumed mean can be reduced by 1 divided by h times, where h is the common factor among the mid-values. For the sake of convenience, we consider h equal to the width of the class intervals in a regular interval of class. Let the step deviations be yi, which is equal to xi minus a whole divided by h. This implies xi is equal to a plus hyi. Let this be equation 1. We know that the mean x bar is equal to the sum of the products fi and xi divided by n. On replacing the value of xi from equation 1, x bar is equal to the sum of the products of fi and a plus hyi whole divided by n. On simplification, the right-hand side of the equation becomes a multiplied by the sum of the frequencies divided by n plus h multiplied by the sum of the products of fi and yi whole divided by n. We know that sum of the frequencies is equal to n. Let the sum of the products fi and yi whole divided by n be equal to y bar. Therefore, x bar is equal to a plus h multiplied by y bar. Let this be equation 2. Let's substitute equations 1 and 2 in the formula for variance. On simplification, we get the variance is equal to h squared divided by n multiplied by the sum of the products of fi and yi minus y bar whole squared. We notice here that the variance that we have deduced here is in the term of variable yi. Hence, this can also be written as variance in the term of variable xi is equal to h squared multiplied by the variance in the term of variable yi. Sigma x squared is equal to h squared multiplied by sigma y squared. On taking square root on both the sides, we get sigma x equal to h multiplied by sigma y. Sigma y can also be written as shown here. This is the formula for the standard deviation in the term of variable yi. Let's find the variance and the standard deviation of the marks obtained by 25 students as shown in the table. The given frequency distribution is shown here. The total frequency n is equal to 25. Let the assumed mean be 16. The deviations of the xi's from the assumed mean, 16, are obtained as shown. As you notice here, the highest common factor among the deviations is 4. Thus, we'll take h equal to 4. Next, yi is equal to xi minus a whole divided by h. The values of the yi's are calculated as -2, -1, 0, 1, 2. The squares of the yi's are obtained as 4, 1, 0, 1 and 4. The products of fi and yi are -4, -5, 0, 7 and 4 respectively. The sum of the products of fi and yi is equal to 2. Next, the products of fi and yi squared are equal to 8, 5, 0, 7 and 8 respectively. The sum of the products of fi and yi squared is 28. The formula for variance is shown here. Let's substitute the respective values in the formula. On simplification we get the variance is equal to 17.81. The standard deviation is the square root of variance, which is equal to 4.22. In this module, you will learn to compare dispersions among series. We know that mean deviation, variance and standard deviation are the measures of dispersion. Let us consider the data given here. The table shows the heights and weights of 5 students of a class. Here we notice that the data are in 2 different units. Hence the measures of dispersions will also have different units. On calculation, we have the means and the variances of the series as shown. How can you say which series is more dispersed? We cannot say which series is more dispersed on the basis of the variance. In such cases, we use another measure that is independent of the units. The measure of dispersion independent of the units is called the coefficient of variation, or CV. It is defined as the standard deviation divided by the mean, and is expressed as a percentage. Here, sigma is the standard deviation and x bar is the mean. The data in a series with greater CV is said to be more variable, while the data in a series with less CV is said to be more consistent. Let's find the coefficients of variation for the given data. The coefficients of variance of the heights and weights are obtained as shown. They are obtained as 3.5 and 2.82 respectively. The CV of the heights is more than the CV of the weights. This implies that the dispersion is more in case of the heights. Let's compare two frequency distributions with the same mean. Let the mean and the standard deviation of the first distribution be x1 bar and sigma 1. Let the mean and standard deviation of the second distribution be x2 bar and sigma 2. The CV of the first distribution is sigma 1 divided by x1 bar multiplied by 100. The CV of the second distribution is sigma 2 divided by x2 bar multiplied by 100. Now, let's take the ratio of the coefficients of variation. We know that the means of the distributions are equal. We get the ratio as sigma 1 divided by sigma 2. This implies that the variability of the distributions with the same mean depends on the standard deviation or the variance of the distribution. That is, the series with the greater standard deviation or variance is more variable. In other words, the data is spread more. Also, the series with the less standard deviation is more consistent.